Students, today we'll discuss about latent heat and the various types of the latent heat. Latent heat, it is the amount of heat required to convert unit mass of a substance. Unit mass, maybe 1 gram, maybe 1 kilogram, 1 unit mass of a substance from one state to another state, from solid state to liquid or liquid state to gaseous state. So when one unit mass of a substance is converted from one state to another state, the amount of heat needed is called latent heat. So during the change of the state, the temperature, even if you continue to supply heat, uh, the temperature of the system will remain same. The temperature will remain same. The temperature will not change during phase change. Change of state is also known as phase change. Change of is also known as phase change. So during phase change, the temperature remains constant. So there are what will be its unit? Heat required per unit mass. So this is represented with L. L is Q by M. So this L is latent heat. So therefore, its unit will be joule per kg. Okay, its unit will be joule per kg in which system? MK system, or per gram in CJ system. Now, what are the types of latent heat? We will discuss here latent heat of fusion and latent heat of vaporization. Latent heat of in latent heat of fusion, the solid is converted to liquid at its melting point. Because when you convert a solid to its liquid state, so the solid has to melt. So heat must be required, heat must be given, so that its temperature will rise. The temperature keeps on rising till melting point of that substance reaches. Okay, so when heat is applied, it continuously raises the temperature of the solid till the solid comes to a temperature that is called where the melting will start. That means that temperature is called the melting point of the substance. Okay, so after that, when you continue to supply heat, then further supply of heat will not increase the temperature. The increase in temperature was previously before melting point was reached. So as soon as the melting point is reached, the heat supply will only change the state of the substance. It will not further increase the temperature of the substance. That we must be very clear. So latent heat of fusion will define that here we convert unit mass of a solid to its liquid state. During this time, temperature remains same. This temperature is the melting point of the substance. This T is nothing but the melting point. So I'll write latent heat of fusion with the symbol LF. Similarly, here what happens? The liquid is converted to gaseous form. Liquid is converted to gaseous phase, and here the temperature will remain constant. This temperature is called the boiling point of the liquid. Okay, that means when you supply heat to any liquid, the heat will increase the temperature of the liquid. The temperature will keep on increasing till the boiling point of the liquid reaches. Once the boiling point comes, the further increase in heat will not increase the temperature of the liquid. Now, further heat will only vaporize the liquid. Okay, it will just start converting the liquid to its gaseous state. So this T here is the boiling point of liquid. This T here is the melting point of the solid. So that we must write. Okay. The symbol you are using here is LB. Latent heat of vaporization. This is latent heat of fusion. Okay. Now we'll define what is latent heat of fusion. So basically what we're doing, we'll take unit mass of a solid, convert it into, so solid is converted to liquid. Heat is required to do so. Temperature will remain constant. So it is defined as the heat that is required to convert solid to liquid at constant temperature. Students, so this is what is the meaning of latent heat of fusion. So unit mass of a solid is converted to its liquid form at constant temperature. All the amount of heat that we are supplying goes only to convert the solid to liquid at its melting point. That means if the solid, suppose I will take ice, it melts at 0 degree centigrade, but suppose that the ice is now at a temperature of minus 10 degree centigrade. Now you supply heat, it will not melt. Okay, that you must understand that every substance or every solid will melt when its melting point will come. That means if we talk generally of the ice, it melts at 0 degree centigrade when the pressure of is 1 atmospheric pressure. That means what? If you supply heat, it will not start melting suddenly. It will start melting when its temperature will come to 0 degree centigrade. So initially, if the ice has temperature 0 degree centigrade, you supply heat, it will start melting. But if the ice is already at some temperature below that 0 degree centigrade, suppose it is at minus 10 degree centigrade, now by supply heat, the ice will not start melting. So by this, the heat supplied will only increase the temperature of the ice. So from minus 10 degrees, for example, if you supply heat, it will raise the temperature by 1 degree, so it will become minus 9 degree, then minus 8, then minus 6, minus 7, minus 5, minus 4, minus 3, minus 2, minus 1. Further it is 0. When the ice is having temperature 0 degree centigrade. Now you supply heat, it will start the ice to melt. So the solid, we have to remember one thing, that the solid will melt or to start melting whenever, obviously by application of heat, when it has reached its melting point. So before melting point, it will not, heat supply will not melt the solid. So for so unit is same as before, because all is latent heat, so it is joule per kg or calorie per gram. If I talk about ice, if you think of ice, latent heat of fusion of ice is 80 calorie per gram. 80 calorie per gram. That means if you take 1 gram of ice at 0 degree centigrade, and if you supply heat equal to 80 calorie, then it will completely melt 1 gram of ice to its liquid state. Okay, so that we'll discuss a little bit here. That that means what? This is my ice solid, 1 gram, and its temperature I have to mention. This is very important. Suppose the temperature is 0 degree centigrade. Now I supply heat, 1 calorie, 2 calorie, 3 calorie. I'll just keep on increasing the amount of heat. So how much heat is needed to completely melt the ice? So this is liquid water. So to convert 1 gram of ice to liquid, and its temperature will remain same, 0 degree centigrade. Temperature will not change during phase change. That we have discussed. The temperature remains constant. So how much is this heat? This heat is 80 calorie. Okay, that is the meaning of latent heat of fusion. So per unit mass, how much heat is required? That is the latent value. If I say this is one, if I say the ice is at minus 10 degree centigrade. Now, if you supply heat, it will not melt. Its temperature will increase. The state will remain same. It is solid now. Here also it will be solid. State will not change. The state will remain same. Temperature will increase from minus 10 to 0 degree centigrade. Whatever amount of heat that you will supply, that is called specific heat of the substance. For ice, the specific heat is 0.5 calorie per gram. That means per 1 gram you require 0.5 calorie. So if you want to calculate, then I will also calculate this. How much heat is required to convert this ice at 1 gram, ice at minus 10 degree centigrade and 1 gram to convert to ice at 0 degree centigrade. So you have to increase the temperature by 10 degree centigrade. That means the amount of heat that is needed to convert this into this form is mass 1 gram. This is 0.5 calorie into temperature is 10. So this is 5 calories. So when I give 5 calorie to 1 gram of ice, which is at minus 10 degree centigrade, it will be converted to ice at 0 degree centigrade. So before the melting point, that will be only rise in temperature. During melting point, that is constant temperature. So these are the few basic concepts we must keep in mind. Okay. So the role of heat is to either increase the temperature of the body or to melt the substance or to change the state. In case of solid, melting; in case of liquid, vaporize it. So this is the case. Now we'll discuss about latent heat of vaporization. So again, we'll take unit mass. So I will choose 1 gram of liquid, and we'll vaporize the liquid to convert it into gaseous state. So the definition is defined as Okay, so this is the meaning. So to convert unit mass of liquid to its gaseous form, and that happens when boiling point reaches the liquid, and temperature will remain same throughout this. So now, just like in case of solid, we'll discuss about latent heat of vaporization. Just the explanation. We have liquid, which is 1 gram. Liquid, which is water. I have taken liquid as water. I want to convert this into gas, vapor. Now it will become 1 gram of vapor. So you have to supply heat. The question is how much heat you want to supply. How much heat can convert this to this form? That heat that you are supplying is the latent heat of vaporization. So this heat that you are supplying is latent heat of vaporization. Now, if the vaporization will start, or the liquid will start boiling when its boiling point reaches. So if you have taken water, the water boils at 100 degrees centigrade. So that means if it is at 100 degrees centigrade, you supply heat, it will start converting into vapor. The heat that I am supplying, in case of water, it is 540. How much is this? 540. So that means you require 540 calorie of heat. So exactly you require 540 calorie of heat to convert water 1 gram when it is at 100 centigrade, to convert it to vapor at the same temperature 100 centigrade in gaseous form. So that is the meaning of latent heat. This is the latent heat of vaporization of water, which is 540 calorie. And therefore, the latent heat is 540 calorie per gram. In terms of a unit, it is 540 calorie per gram. This is for water. Okay. Now, so that's all in this video. We'll move to the next topic. Okay. Thank you.